Hey all, welcome back to our channel. I'm back with another interesting programming interview question from LeetCode, that is finding number of digit 1. Okay, given an integer n, count the total number of digit 1 appearing in all negative integers less than or equal to n. Okay, for this problem I'm going to show you two solutions. One is without optimization and the second solution is with optimization. Okay, for example, let's take if n equal to 13, the output should be 6. Okay, and then if n equal to 0, output should be 0. Let me show you the first solution. Okay, for that let me create helper function to convert a number into an array of its digit. For that, let me create helper function digits. For this, I'm passing number. Inside this, I convert the number into string and then split. Okay, split into characters. After that, map back to numbers. Okay, map number. This helper function simply converts the given number into string and then split and map back to number. So this gives number of or digits of given number. Now let me write the main function to count the number of ones appearing in given number from 1 to given number. Okay, from 1 to given number. For that, count of digit appearing equals to, again pass the number as an argument. Inside this function, let's create a variable digit count to keep track of the total count of ones. Okay, initialize with 0 and then use for loop to loop through or loop over all numbers from 1 to up to the input number. Okay, I less than or equal to number I plus plus. Okay, let's create a variable digits array digits of I to get digits of the current number. Okay, this is to get digits of the current number. Now let me take another for loop at j equal to 0, j less than digits array dot length j plus plus. Okay, inside this for loop, what I'm going to do is check if the digit is 1. Okay, if digits array of j equals to 1, I simply increment the count. I simply increment the count of ones. Okay, for that digit count plus equals to 1. Okay, so after both for loops, I simply return the final count, digit count. Okay, let me show you running this program with an example. I'm going to take the same example which is given in our LeetCode, that is 13 and equal to 13. Okay, let me run it. We got an error. Okay, here it's caps. Let's run again. Yeah, if you see here, the output is 6. Expected output is 6. So let me print even the indexes where we are actually having digit 1. Okay, in which numbers we are having digits ones. Let me print this so that we'll come to know. You see 1, 10, 11, 11, 12, 13. Why? Because in 13 we have one digit. In 12 as well we have one digit appearing. In 11 we have two one digits. That's why we got 11 twice. And then 10 and then 1. So from 1 to up to number, how many one digits appear? The total count is 6. Okay. This is the first approach where we used one helper function to convert number into digits, and then we used two for loops to loop through the given number to check one appearing or not, and then based on the condition we are incrementing the count. Okay, this is about the first approach. Now let me show you the second optimized approach. After that I will even show you the difference between these two solutions. Okay, for that let me go to second editor and then let me show you the optimized approach. Okay, for that let me create one function count of digit appearing. Okay, and so inside this function let's create a variable let count equals to 0 to hold total number of ones. Okay, after that let me take one for loop inside. Okay, for I equal to 1, this is to loop over each digits place. Here we are taking the approach based on the digits place, that is units, tens, hundreds, like that. Okay, I less than or equal to n, I star equal to 10. Okay, now inside for loop let me take one variable, that is divider equal to I asterisk. Okay, I asterisk 10. This divider to separate the current digit place. Let me take, or let me show you the mathematics formula which will count the total number of ones appearing in given number. Math dot flow. I will explain the formula after writing here. N divided by divider asterisk I plus math dot min, math dot max, and modulus divider, n modulus divider minus I plus 1 comma 0 comma I. Okay, this is the mathematic formula we are using to count the ones appearing in given number. So let me explain this formula. So the first part till here, it counts complete group of I where one appears in this place. Okay, in this place. Next, in this digits place, the next formula, that is n modulus divider minus I plus 1. Okay, this counts leftover occurrences of ones in the current partial group. After that, this math.max ensures we don't count negative values. Okay, and the final, that is math.min. This formula limits the count to at most I for the current place. Okay, this is after this line of code will get the complete count of number of ones appearing. Okay, finally let's return the count. Okay, now let me run this program by taking the sample input provided in the LeetCode problem. Okay, 13, and then let's run. Okay, we're getting error again. Console. Okay, console. Sorry, console. Yeah, console. Let me run it. See, the output is 6. So both normal version, there is without optimization, and then optimized version, both giving the same output. But let me show you the difference. When the number is large, then we'll get to know the difference. Let me run with the optimized version without without the optimized version with a large number like this. Now let me show you how much time it will take. You see here, it's running. So it took some time. The same thing, let me run using optimized version. Let's observe here how much time it takes to display the count. See, if you see the difference here, the without optimization, it's taking more time if the number is bigger. It's running. You see, if you observe here, it's running. So as we increase the number, the time to execute increases. See, it's taking lot of time to execute or to count number of ones appearing in a number if the number is large. It's taking. Meanwhile, let's go and check with optimized version how much time it will take. See, it's still counting here. So that is the difference between two approaches. See, now we got the total count. So this approach, though it's giving solution, but this is not the optimized version. So this is the optimized version which counts number of ones very fast, even the given number is bigger one. Okay, thanks for watching. This is all about the LeetCode problem. If you like the video, please do like, share and subscribe for more technical interview videos. Thanks for watching.